This video covers complex numbers, page 31, question 11. So this question asks us to show that if z equals cos theta plus I sine theta, that 1 over z equals to z conjugate. So I'm going to start off by putting 1 over z. And you've got a couple of options here, by the way. You can leave it in polar form to start off with, or if you like, you can change it into rectangular form to begin with and then just do your regular complex number division. Either approach is actually totally fine. I'm going to stick with the polar form approach for the moment. So 1 over z equals 1 over cos theta plus I sine theta. Okay, so I want to do division with complex numbers in polar form. So, well, that 1 isn't in polar form currently, so I want to change that first of all. So pause the video for a moment. If a complex number is 1, or if you prefer 1 plus 0i in rectangular form, figure out what it is in polar form. Pause the video while you do that, and then once you've that sorted out, play and continue on. So 1 plus 0i, which is just written as 1 here, can be written in polar form as 1 cos 0 plus I sine 0. And you'll notice there in the bottom, the denominator, I've just put in my modulus in front there just for completeness. And now I want to use the rule for dividing complex numbers in polar form. So I divide the modulus and then I subtract the angles. So how is that going to look? So the modulus is just going to be 1. And when I subtract the angles, it's cos 0 minus theta plus I sine 0 minus theta. Now I can tidy this up obviously by getting rid of the 0, but it still looks a little bit messy. I'd like to even maybe tidy this up a little bit further. So to do that, I'm going to go to my log tables. And on page 13 of the log tables, I can see this little section here. And this tells me what to do when I've got cos of a negative angle and sine of a negative angle. So the cos of a negative angle is just cos A, and the sine of a negative angle is minus sine of that angle. So I'm going to apply that now to my complex number here in polar form. So cos of negative theta can just become cos of theta. And then sine of negative theta would be minus sine of theta. So I'll say minus I sine theta here. So let's look back now to what the question was asking us. It was asking us to show that 1 over z equals to z conjugate. Well, what's z conjugate? So z conjugate is what I get when I change the sign of the imaginary part of a complex number. So in this case, z conjugate is just cos theta minus I sine theta. So notice the result that I got for 1 over z is exactly that. So I'll conclude now by just making that statement. So first of all, just noting that 1 cos theta minus I sine theta equals cos theta minus I sine theta. And then finally, 1 over z equals to z conjugate.